In number 15, we're looking at the fifth root of negative 32x to the 10th y to the fifth. And call this overkill, but I like to write it out the way my brain thinks about it. My brain has to think of each one of these things individually. This is like saying the fifth root of negative 1 times the fifth root of 32 times the fifth root of x to the 10th times the fifth root of y to the fifth. And then at the end, once I'm through simplifying each one of these things, there could be something that's left in the fifth root, and there could be some things that are on the outside. But let's see, this is just scratch. So the fifth root of negative 1, that comes out, and it's just negative 1. If it was the even root of negative 1, it would be I. Okay, but it's an odd root. The fifth root of 32 is 2. The fifth root of x to the 10th, well, since we're not taking a fifth root of a number this time, it's the fifth root of a variable to a power. I have to say, how many times does 5 go into 10? And 5 goes into 10 2 times evenly. So an x squared comes out, and nothing as far as the x stays inside of the radical because it went into the 10 evenly. And now the fifth root of y to the fifth, well, 5 goes into 5 one time, so a y to the first comes out. It went into there one time evenly, so nothing in this problem stays on the inside. And the final answer would be negative 2x squared y. Have the negative cube root of a to the 12th divided by 243 b to the 27th. Now, I will again show you how my brain works here. It looks at the cubed root of every part of this expression. So the cube root, now notice our final answer will be negative, okay? But the cubed root of a to the 12th, well, 3 goes into 12 4 times evenly, so that's just an a to the 4th that comes out, and there's nothing that stays inside of the cube root because the 4 went into, the 3 went into 12 4 times evenly. So now I look at the cubed root of 243. And if you type that into your calculator, there's not a cubed root of 243, so we just have to simplify that radical. And I do that by writing 243 and dividing it by prime numbers. So like 2, well 2 doesn't go into 243, but 3 does. 3 goes into 243 81 times. And yeah, 9 times 9 is 81, but I'm dividing it by prime numbers. So let's do 3 again. So 3 times 27. And 3 times 9. And 3 times 3. So I stop here because 3 is prime. So these are all prime numbers that go into 243. And since I'm taking the cubed root of 243, I look for the 3 that repeats 3 times. Okay? And I would bring that 3 outside of the radical once. And then I would multiply the remaining 3's that don't repeat, or the remaining numbers that don't repeat 3 times together. And so 3 times 3 is 9. So 3 cubed roots of 9 is the same thing as the cube root of 243. And now I just move to the cube root of b to the 27th. And that 3 goes into the power 9 times. So it would be b to the 9th. And just to clean this problem up a bit, we could write it as a to the 4th over 3b to the ninth cube roots of 9. And that looks just a tad bit better.